Hello everyone, my name is Nilma. Today I am going to explain about the topic registers. We are going to discuss all the introduction about registers and about the buffer register, control buffer register, shift register, and shift left register, bidirectional shift register, and all the types CISO register, SIPO, and PISO and PIPO registers. After that, we are finally going to discuss about the universal shift register. And the introduction part of our register is knowing about a register. That is, a shift register is a group of flip-flops which are connected in series to store and shift multiple bits of data either left or right using clock pulses. And the register that shifts the bits to the left is called shift register, and the register that will shift the bits to the right can be known as shift right register. Based on the data loaded and retrieved from the register are classified into four types of which are CISO, SIPO, PISO, and PIPO, which can be known as serial in, serial out, and SIPO serial in parallel out and PISO parallel in serial out, PIPO parallel in parallel out. At first, we are going to discuss about the buffer register. A buffer register in digital electronics is a storage unit that holds binary data and built using a series of D flip-flops, which with each flip-flop storing one bit data. And the data is loaded into a buffer register at each clock tick with outputs matching input bits at each leading clock edge. And its primary function is to act as a temporary storage area for data being transferred between devices or components, helping to match the different speeds of faster and slower devices. As here we can see the buffer register diagram where there is a D flip-flop. Here we are going to use four flip-flops and the flip-flop will be taken as a D flip-flop. And here these are all the clocks. Clocks are connected to the every flip-flop and the inputs A, B, C, D are connected to the D flip-flop and the outputs Q are connected. And after the buffer register, we are going to know about the control buffer register, which is a buffer. It is also a buffer register with lack control over inputs, causing uncontrolled outputs. To fix this, control buffer registers are used. In this design, tri-state switches are used to control the operating of loading and retrieval of the data to, to the buffer register. Here, one has to pull the LD or WR control line, which is indicated in a blue line in this diagram. Low, which is a low in order to store the data into the register, while RD control line, which can be seen in a red line in the figure, should be made low to read the data. After that, we are going to discuss about shift right register, where we already discussed about that above. The register that transfers or shifts input data to right side is called the shift right register. When the rising or falling clock edge arises, then the stored bits shift rightward according to the one bit position per clock pulse. Then the data is entered into the register from the left side and the data is retrieved from the right side. As well as we can see this in this figure where we considered the 4D flip-flops and for each flip-flop we connected the clock here and here we give the D input and the Q output is connected to the another D flip-flop Like that we are connected here. Now we are going to talk about shift left register. The register that transfers or shifts input data leftwards is called the shift left register. When the rising or falling clock edge arrives, then the stored bit shifts leftward according to the 1 bit position per clock pulse. And the data then is entered into the register from the right side and the data is retrieved from the left side. So that's why we considered in this order 0, 1, 2, 3, 4 D flip-flops and D in is given this side as well as it is a shift left register. But in a right shift register we had given D input from left side. Now we are going to discuss about bidirectional shift register. This type of register allows shifting of data either to the left or to the right side. It can be implemented by using logic gate circuitry, which enables the transfer of data from one storage to the next stage, to the right or to the left, depending on the level of the control. And the right or left is the control input signal, which allows data shifting either towards right or towards left. And the right or left is the control input signal is low. Then the data in the shift registers goes towards the left. And then when the control input signal is high, then the data is in the shift register are going to enter towards the right side. For the bidirectional shift register, here is the circuit diagram. Here we can see the total operation and working of the bidirectional shift register. As time we considered four flip-flops, D flip-flops as well. And here we taken the shifter here. This can be known as a shifter here. Now we are going to discuss about the four types. At first, CISO, which is a serial in, serial out shift register that accepts the data 1 bit at a time through a single line, input line, and outputs data serially, that is, one output at a time. The data enters and leaves 1 bit at a time in a serial sequencer, typically made of multiple D flip-flops connected in series and synchronized by a common clock. Here we can see the common clock is connected to the four flip-flops and as per the sequential series, we connected them and four D flip-flops are used. Here is the serial input, here is the serial output. After that, SIPO register, which is a serial in parallel outer shift register that accepts data 1 bit at a time through a single input line and outputs data parallelly through multiple lines. The data is the input 1 bit at a time and outputs all stored bits in parallel. We can see, hence the parallel number of outputs are coming here so that we use it clear to all the signals, all the flip-flops, and we connected the clock to all the four flip-flops. Here is the parallel output. We can see as it has the upside. After that, PISO, which is a parallel in serial out shift register that accepts data multiple bits at a time through multiple input lines and outputs data serially through a single line. Here we can see the multiple inputs are coming from the shift. And finally, the serial output will be come out as a only one serial output, and the clock is connected to the all the four flip-flops. Finally, we are going to discuss about the PIPO register, which is a parallel parallel out shift register that accepts data multiple bits at a time through multiple input lines and outputs data in parallelly through multiple lines. As we can see here, the for all that clock is connected to the four flip-flops. Hence, here it takes the parallel inputs. So we connected the D like this, and in each state it gives the parallel number of outputs as well. Hence, in each flip-flop we get the every output here. The upper side is all the parallel inputs, and the lower side are parallel outputs. At last, we are going to discuss about universal shift registers. A universal shift register is an n-bit register that supports both left and right shifting as well as parallel loading using n flip-flops and n multiplexers with shared select lines to control the data flow. It combines the features of bidirectional and unidirectional shift registers, enabling versatile data manipulation such as shift left, shift right, parallel load, and hold. Here we consider S0, S1 and operation. When it is 0, 0, hold operation will take place. And when it is 0, 1, shift right operation is going to happen. And when it is 1, 0, shift left is going to happen. And 1, 1, parallel load is going to happen. Clear? I hope we discussed about all the topics in the registers. Thank you.